Okay. My name is Robert Franklin. I'm conducting an oral history interview with Don Baker on April 5th, 2017. The interview is being conducted on the campus of Washington State University Tri-Cities. I'll be talking with Don about his experiences working at the Hanford site. And for the record, can you state and spell your full name for us?
My name is Donald E. Baker. Uh, it's spelled Donald, initial E, last name Baker.
Great. And do you prefer to go by I should ask you beforehand, Don or Donald?
Don is fine.
Okay.
Either one, I'll respond.
Okay. Great. So, Don, tell me how and why you came to the Hanford site.
Well, I had heard very little bit about Hanford, but early in the school year, June it was probably March or April of 1951, an interviewer from Hanford came to the University of Idaho. And I was a graduate student there at the time. I was interviewed for work over here, and then eventually ended up hiring on, and I reported for work in Richland on early June of 1951.
And what was your graduate degree in?
My graduate degree was in chemistry. I was part of a group of probably over 200 recent graduates that came in that year and hired on with General Electric. General Electric was the contractor at that time that was in charge of the entire Hanford project.
Wow, okay. Did you have any idea? Did you interview for a specific job at Hanford, or?
No, I didn't. I at that time, really there was not a lot known to the general public because it still was a very classified operation that they were running here. And so I just assumed that with my background in chemistry that I would find some interesting work here. And I certainly did.
Yeah. Did you have any other job offers, or had you interviewed at many other places?
No, I really was interested in knowing more about this.
Okay.
And this would have probably been my first preference, and definitely after I knew more about it, I knew that I had made a good choice. But the conditions here were, shall we say, a little rustic at that time as far as living conditions. When I reported here, I was offered living accommodations in a barracks-type dormitory building in North Richland. And I was there for approximately, maybe 2 or 3 weeks. During that time, we were given orientation lectures and so on. And at the end of that 2 or 3 weeks time, I was offered to do some work in off-site inspection. Now, off-site inspection was a group of engineers that were following contracts where equipment was being built for Hanford. Quite a ways away from chemistry, but nevertheless, it sounded like an interesting opportunity for me because it could give me an opportunity to see just what the real world was like as far as how equipment was fabricated. So after that, being here for only about 3 weeks, I packed my bags and was off to Milwaukee, Wisconsin, to a plant that was fabricating some approximately 1 cubic foot containers for some work here at Hanford. And this was in a foundry type place where heavy vessels were fabricated. this particular company was known for their huge beer processing vessels. That the tanks were made for making beer that were glass lined. They were made out of carbon steel, and then they would have go into a huge furnace where a glaze was put on the inside of the tanks. That was quite a ways away from the type of work that Hanford was requiring them to do. They were making approximately a 1 cubic foot vessel to extremely tight specifications that the people found hard to believe or understand when they first started the job. It was a stainless steel tank that had an off-center pipe in it, and it was made to very tight specifications, dimensionally to within 1,000th to 3,000ths of an inch, and it had a special fitting on the top to connect to equipment that it would be used on here at Hanford, and it had to be leak tight so that it would only leak approximately 1 cubic centimeter in 30 years. That's tight.
Yeah.
And so, and also cleanliness specifications that were really unheard of. After the container was fabricated, it would be fired in a huge tank-like furnace with hydrogen present, and that would turn this into a shiny metal vessel. From that point on, it could not be touched with bare hands. This was really, really difficult to impress on the people that were fabricating, because they were used to handling anything with whatever old leather gloves they had, because there was to be no fingerprints or anything like that on there, and it was to be completely clean. Well, that went well, because as soon as they figured that the inspectors that were back there would reject anything that they saw that was handled without white gloves, they caught on in a hurry, and we had no trouble from then on. And the job was completed, and they did an excellent job on making these containers for us. The next assignment that I had after that was about 3 months that we worked on that particular contract. I then went to an aluminum company in Pittsburgh, Pennsylvania, and they were making aluminum process tubes that would be used in the reactors out here. And this was really interesting to me to see the way that they proceeded to make these. They would start out with a billet of aluminum, maybe 3 or 4 inches in diameter, with a hole through it. And by successively pulling that aluminum through dies, they would reduce it from the original dimension down to a process tube that was approximately 1 3/4 inches in diameter and roughly 42 feet long. Not only was it a long tube, it had ridges at about 4 o'clock and 8 o'clock to support fuel that would go in there and allow for water circulation all the way around the fuel. So as they would draw this, these little ridges would gradually go down until they were exactly where they were. And also, there could be no twist in this. So if the ridges were at 4 o'clock and 8 o'clock at one end of the tube, they needed to be the same location at the other end of the tube. But they were very experienced in doing this type of work, and they proceeded to do a fine job for us. After the tubes were inspected and approved for shipment, they would slide like a cardboard sleeve over the outside to protect them. And then these were placed in long wooden boxes. And now we hear a lot about recycling, but at that time, it wasn't in everybody's vocabulary, but they needed some wooden boxes, and somebody out here at Hanford said, you know, we had had some previously orders of these tubes. Where are the boxes? And they said, oh, these boxes have been surplused, and somebody comes in and they have an auction out there and bought them all up. Well, it turns out that the very boxes that we needed were in a surplus yard out in West Richland. The people here, with recycling on their mind, contacted the person, bought them back from him after he had bought them here, shipped them to the plant that was manufacturing the tubes back in Pittsburgh, and they loaded them up. And then they had to go in a special rail car. Normally, box cars have side opening doors. This had to have an end opening doors on it so that the tubes, 40 some feet long, could be put in this 50-foot box car. Then a bulkhead was built in the end of the rail car in there so that the load could not shift, and it was stacked to probably about 8-9 feet high in the box car and shipped out here and unloaded out here on the plant. So it was interesting to see how they proceeded to do this, and this would have been in 1951. And interestingly, that was about the time that commercial household aluminum foil came onto the market, and it was much in demand, especially for the holiday season in December there, and the employees and people at this plant could buy the aluminum foil at the company store there when it wasn't available commonly in the supermarkets and so on. But some of these things, you know, we take for granted now that they've just always been there. But this company was making all kinds of things, including process tubes for use at Hanford. Then after that project was completed in 3 or 4 months, I think we were there, I was assigned to another one in Ohio. The process tubes on the reactor go in through a steel tube that is called a gun barrel. And this gun barrel is approximately, I would say, maybe 7 or 8 feet long, and it had stepped areas on it so that radiation could not stream out of the reactor. It would be stopped by the steel at different intervals along there. Again, this was something that had to be made to within at least a 1,000th to 3,000th clearance on every dimension. It was made of steel, and the company that had the contract to make these could not fulfill their contract. They failed, and the contract had to be taken away from them. They were months behind, and they had created a huge pile of scrap, and that was all to show for their experience. So the contract was canceled, and it was given to another company that was doing work exclusively for the U.S. Navy. And in fact, they even managed to get some of the special tooling that was only available that belonged to the U.S. Navy, and it was applied to our job. They put the job, they got busy on it and came through beautifully, and they were able to use these because the construction really, it was essential. They couldn't go ahead and put the process tubes in the reactor that was being built at that time until these components were in place. Sure. So it was pretty straightforward once they got the right people working on the job, and again, they came through and provided what we needed out here. So this pretty much takes care of my first year of employment here. I came back to Hanford, and I was at that time I still did not have my security clearance, so I was assigned though to the B reactor area, and worked with an engineer on an efficiency study for the power plant. Some of these seem a ways away from chemistry, but nevertheless, we did do chemical analysis on the combustion products from the coal plant, and they were looking for just small improvements in the efficiency, because coal was a big expense for here as far as producing steam. The steam was needed to heat the facilities out there, but it was also used as part of the high-pressure pumping system for the reactor. They had an electric motor, and on that same drive shaft was a steam turbine, so that if the electric motor lost its power, the steam turbine would pick up the load and supply high-pressure water to the reactor until it would get cooled down. So it was a backup for loss of electric power as well. So I worked at that, and about 6 weeks after I started in on that project, my security clearance came through. And that's what I'd really been waiting for. And I got notice of that in the morning, and in the afternoon, the engineer I was working with, my manager, took me over and showed me B reactor for the first time. And of course, I was quite impressed with what I saw, and it gave me a chance too to see where some of these components that I had observed being made across the country, where they were being used out here at Hanford. So after we finished up the steam plant study, and by the way, we found out that they were doing a good job as far as the operators. There wasn't much that we could uncover that would improve their operation. The thing that really made a difference was the quality of coal that they were buying. If they bought coal that was of low quality, cheap, they didn't get good results from it. So that was kind of what we learned from that. But we still knew that no further improvements could be made as far as we could tell. I then went, after that I spent some time, 3-4 months with the reactor operations group, and then I was offered an opportunity to do work on graphite research. Graphite had become a really, really big problem. It was going to be limiting the life of the reactors, and they could see that was exactly where things were headed. This was again in 1952. And so they had two large groups of people, a graphite research and a graphite development group, that were studying what to do with this problem. In the meantime, DR reactor had been built, because they could see its lifetime was fast approaching, end of life, and the plan was that they could then just switch the water plant from once D was shut down over to DR and just move on from there. Well, as it turned out, with all this intensive effort, they found ways that they could minimize the expansion that was occurring in the graphite. Up till that time, they had been keeping it nice and cool, helium atmosphere, And as it turned out, the graphite was really being damaged more by those low temperatures than allowing it to go a little higher in temperature. Because every time a fission reaction would occur, a very energetic neutron, about over 2 MeV neutron, would be generated, and this would interact with the atoms in the graphite and cause it to swell. And so by operating at a little higher temperature began to relieve some of these problems. But there was a tremendous amount of research that went into there. We would be putting, I was then with a group that would be putting samples in the reactor, taking them out at 6 weeks to 2-month intervals, and measuring them in the 300 area laboratories, and then returning them back to the reactor. This way, we were able to learn a lot about what was happening and how to make the reactor measurements so that we could improve the operating characteristics of the plant. They all, in addition to physical measurements, expansion and so on, they measured the conductivity, and this was one of the areas that I got pretty heavily involved with. How well the graphite would conduct heat determines, to a large extent, what the temperature is going to be in there. So typically, the traditional method was to take a large cylinder of graphite, put a heater in it, and measure temperatures in it as a function of power input and all that. So it was about that time that somehow or other I ran across some work that was being done at a U.S. Naval Research Laboratory in San Francisco area. So I contacted the physicist down there and asked him about it. He invited me down there. He said, well, I can't tell you exactly what we're doing with this, but he says, I can show you our equipment and you can take it from there. So it was a different approach and exactly what we needed to be able to measure the thermal conductivity of graphite from the reactors out there. What they used was putting a pulse of heat into a very small piece of graphite, smaller than the size of a dime. And they would put a pulse of heat in there and then measure how fast that heat pulse traveled through this thin sample. And from that, you can derive the thermal conductivity, just what we were looking for. We were able to build equipment that would go into, from the front face of the reactor, go into an opening in the reactor where the process tube had been removed, and the saw would rotate 90 degrees and remove a plug of graphite from the inside of that graphite channel. Then we would take that into our lab, slice it up into pieces, and we could tell exactly how the conductivity was changing from the area where the cold process tube was in contact with the graphite to out to the edges of the graphite blocks. This provided us a lot of data that hadn't previously been available. So we built the equipment here to do that type of measurement. They were using flash tubes as the pulsed heat source, but it was flash tubes that would be used for aerial night photography. And so these were pretty powerful flash tubes, but approximately a year after we started using that technique, lasers were developed, and then we started using pulse lasers, which were a big improvement. And from then on, it was pretty much a standard way of measuring conductivity on small samples. And in fact, because that capability was available here, one of the things that had been done was to recover a large amount of technetium. Now, technetium is not available normally. It's an element in the periodic table. I don't remember just which number now, but all of it that ever was available, if it was, is had since decayed. I think it has about a 4 million year half-life, very long half-life. But it is a fission product, and they were able to process enough fission products to come up with technetium that could be converted to the metal. And one of my engineering friends out there worked on this project for quite a while. And so we got to talking one day, and I said, what are the chances that I could get a small piece of that technetium? He said, just fine. He said, we can make that available to you. So I was able then to report for the first time the thermal conductivity of technetium, reported in the literature. So I really had some interesting assignments along the way. Much of the work on graphite was documented in a book called Nuclear Graphite. It was compiled, edited by Dr. Richard Nightingale, and it brought together a lot of information on radiation damage in graphite material. And this then led into, well, go back a step there. Battelle came on the scene in 1965. So my employment then changed to from General Electric to Battelle.
Because you had been working at Hanford Labs, right?
Yes, I was working at Hanford Labs at the time, so that part of it went to Battelle, the research side of it. And we continued to do graphite research until about 1968 or 69. And at that point, Westinghouse was given the contract to do some preliminary work on the fast flux test facility. We had a pretty good handle on the graphite problems at that time, and there were still, though, questions on materials for using them in a much higher flux environment in the fast flux reactor. So we were assigned the task of doing some testing with boron carbide. Now, boron carbide is another interesting, very high temperature material. It has a melting point of about 2350 Celsius. Incidentally, the graphite, to go back a step there, is made from petroleum coke and petroleum distillate, some of the byproducts of processing petroleum. When it's just in the form of coke, it's similar to what the charcoal that we might use in our barbecue. But if it is mixed with other carbonaceous products, made into graphite, and then heated up to 27 to 2900 degrees Celsius in electric furnaces, it will turn it into this material that is used for electrodes in electric furnaces. Electric furnace melting is common in the steel industry. So when it came time to produce all the graphite that was needed for the reactors out here, already in industry there were a lot of people that knew a lot about graphite because they had been in the process of making this for electrodes for many years. So then to get back, we moved into the boron carbide research, and work was done at testing facilities in Idaho. The problem with boron carbide is that it produces a helium, an alpha particle, a helium atom for each neutron that it captures. Boron-10 is an excellent absorber material to use in controlling reactors, but it does have the disadvantage that it produces gases. So the boron carbide is made in the shape of small pellets, about half-inch in diameter, and they are, when they're processed, some of the helium is retained in the crystal structure of the boron carbide pellet, but the rest of it is released into the steel pin that contains it. So eventually it pressurizes the pin and limits how long a control rod will operate. So our assignment was to figure out under what conditions the helium gas was released and what improvements could be made to make the boron carbide control rods last as long as possible. There was also another thing that was unknown at that time, and that was if a tube should fail and if there was sodium flowing past it, would it wash out the boron carbide pellets that was in there or not? Well, we actually set up an experiment to do that with some facilities back at Westinghouse in Pittsburgh. They were able to flow sodium over a simulated failed pin, and we could examine what happened. So this was a type of work that involved high-temperature materials that turned out to be the career that I worked on. It was chemically related, but very materials-oriented, and I found it to be a fascinating career to be associated with. It really was something where there were a lot of problems and a lot of challenges, and so we were able to supply the answers to a lot of that. So that work pretty well continued up until the about 1986 or so, when I became involved in a group that was doing experiments in the FFTF. There was a need for information on fusion energy at that time as to what kind of materials could be used in what they called the blanket of a test machine that was being designed. And so we were able to work with Canadian scientists and Japanese scientists on coming up with an experiment, a design of an experiment that would be placed in the FFTF. This was probably one of the most difficult, most challenging experiments that I had in my whole career at working at Hanford, because the experiment was fully instrumentated so that you could follow everything that was happening, and yet it had to be completely fail-safe. So if the experiment failed, the reactor could continue operating without shutting down. And we succeeded in designing the experiment. The Canadian scientists were extremely helpful in designing part of the tritium recovery, because tritium was what we were producing in these tests, and every bit of tritium had to be recovered. And we had a large glove box. It was about 12 feet high with multiple glove ports. We'd reach in at different levels and operate valves and equipment inside of it. Many challenges, and it operated absolutely perfectly the whole time.
Wow.
And it provided a lot of data. Battelle was responsible for compiling, reporting the data at many conferences. The experiment continued until an experiment was in place when Hanford received the orders from Department of Energy that the FFTF had to be shut down, and we had to terminate our experiments at that time. But it seemed like we really got a lot of important information as a result of the experiments that were done. It turned out to me to be an exciting career to be involved with. So that kind of summarizes quite a few years of interesting work at Hanford for me.
Well, what was the tritium used for when
The-
that was being created?
The tritium, the tritium eventually was used for the weapons program, but it was more of a byproduct of a material that was being used for control rods, because control rods were used in all the reactors out there, and since it could build up pressure inside of the tubes, we needed to know how much, and there even was some work that we were involved with that in putting a metal centered, like an escape valve, on some of the pins, so that as the gas would be produced, the helium could be released without allowing sodium to go back in. But it was not highly successful, and we gave up on that after not too much experimental work. But the combination of sodium being a reactive metal, as it is, we had a lot of challenges too. Oh, another interesting part on the graphite work that we did was, in addition to looking at dimensional changes that were causing the graphite to expand and contract, in some cases too, after a certain point it would contract. So you had peaks and valleys in a channel through the reactor, and they tried to go in and bore that hole out so that it would be easier to slip a process tube through. And in some cases they were successful, but the graphite, after it's irradiated, becomes extremely hard, and they had to use carbon tools to even cut it. We use carbon tools all the time in the laboratory because otherwise metal saw blades just wouldn't do it. We had to use diamond blades to cut it. It was so hard.
Wow.
But we also were interested, once they learned that, to use a gas mixture, a mixture of CO2 and helium to adjust the temperature. This was the key to controlling the expansion that was limiting the life of the reactors. Once we started using that, then we needed to know, in a radiation field, will carbon dioxide react at a different rate with carbon? Because at a high temperature, CO2 plus carbon will produce carbon monoxide. So we put together our own high radiation level cobalt source in the 300 area. I went out looking again. It was the recycle route. We found a surplus tank that had been used was going to be used for some separations processing work, but it was no longer needed. It was about 8 feet in diameter and approximately 15 feet tall. And we found a building in the 300 area where we could dig a hole that deep. In fact, we dug it a little deeper than that and managed to prepare a tank-type facility to make a cobalt-60 irradiation source. The tank was just about even with floor level, went down 14 feet, filled with water, and had a barrier all the way around the top of it, filled with distilled water, because we didn't want to have some of the corrosion products that will happen if you have aluminum in contact with mineral water. But loading it with cobalt was another challenge. We started out with about 15,000 curies of cobalt, which gave us a pretty good source, but it wasn't what we really needed. So over approximately 3 or 4 years, we were able to increase that to 630,000 curies of cobalt-60. That is a lot of cobalt-60. At that time, it was probably the 5th largest cobalt facility in the United States. It had produced radiation levels of approximately 17 million Roentgens per hour. It was without the water shielding over it, the radiation would have been lethal in fractions of a second. But with 14 feet of water shielding us, we could look down at the blue glow, and we would have our experiments suspended above that would go down into 1 or 2 inch tubes, right down to the within an inch or 2 of the cobalt. The cobalt rods were approximately 16 inches high. The cobalt was made locally out in the K-reactors, and transporting it was another interesting challenge. We would ship it in from the reactor area in a lead-filled container cask. The container, the cask would be located down into the water, a lid removed, the cobalt elements would be placed into it, the lid would be placed back on the container, it would be brought to the surface of the water, then with all that, it was approximately 40 inches in diameter. With that much lead around the cobalt, we could approach it, and they would put very secure bolts in the top of it. But then it would be removed from the water, and we had an 8-hour time limit to get it from the 100 areas down to the 300 area and into water again, because there were limits on how much heat could be absorbed in the lead shielding. So we had a crane capable of lifting several ton cask that was set up ahead of time. A section of the roof on this building was removed. The cask would be lowered down through the roof down into this water-filled tank that we had, and we remotely took the cap off, took the cobalt-60 elements out, and we had our own cobalt-60 source for examining materials to see what the effect of gamma radiation would have on the materials. But quite interesting that whenever they had that shipment, patrol cars would be stationed at each railroad crossing, and the patrol cars stopped the trains while the trucks went through.
Wow.
But it was planned in advance, and everything worked fine.
What kinds of materials were you testing next to this cobalt for gamma radiation exposure?
We were testing such things as camera lenses, for example. But mainly its justification was to see whether the cobalt, the gamma radiation would enhance the reaction of carbon dioxide with the graphite. Would there be more reaction going on as a result of the gamma radiation present than not? And what we found was that it wasn't really significant. It was primarily a temperature-controlled reaction, and so we had already were aware pretty much of what the limitations on the graphite temperatures would be. We had thermocouples to measure, and there were thermocouples also that were built into the graphite moderator stack at the time the reactor was built to measure the temperatures. But on one occasion, we did make a periscope. One of the engineers that was working in this graphite group made a periscope that fitted into the front face of where a process tube had been removed, and it matched up against the seal where this gun barrel type arrangement that penetrated into the graphite stack was. That slid in there, and the light, the glow from the graphite went down. A series of mirrors was reflected back to the other one and back again, and so we had a periscope that we could physically use an optical pyrometer and measure the temperature of the graphite using that kind of a device. It was probably the first and only time that we'd able to look into an operating Hanford reactor. But the engineer that was involved with that was a very talented individual, and he came up with something that no one else had thought of doing up until that time.
Wow. And what year would that have been?
That was probably in about somewhere in the late 1960s.
Late 1960s. Wow. That's really quite amazing.
Yeah. No, it was probably earlier than that. It was the late, probably early 60s, probably around 1960 to 62, something like that.
Oh, wow. Okay. So cobalt's a gamma emitter, correct?
Yes, it is.
And so 14 feet of water then was enough to blunt the gamma rays to be able to observe.
Yes, it was.
Wow,
Mm-hmm.
that's really...
Yeah, it absorbs that radiation. It's an ideal material because you can look down there and see what you're doing, and you have to have long tongs, manipulators to work with things. But it has a very penetrating gamma ray that's emitted. I think it's around 1.5 MeV or something like that. So it's a very energetic, very penetrating ray. Some gamma rays or beta particles, for example, do not penetrate like a gamma ray would. But it has a short half-life. As I recall, it's something around it was around 5 years, 5.7 years. I'm not sure of that. But so half of it would decay, and after we made the final really big load, we had 630,000. That was pretty much maxed out as far as the amount of cobalt in that facility, and they just continued to use it probably for at least 25 years after that, and exploring effects of gamma radiation on various materials.
Because then after a certain point, so much of it would have decayed. That
Yeah, a certain amount would be decayed. It still was being used at the time when they started to. Well, I guess it had the cobalt had been removed. The facility was there when they were cleaning up Hanford. Now that facility has been completely removed, the building and all traces of it now I think are gone.
Oh, sure.
But it was used for quite a while.
And that glow you were talking about, that's what's called Cherenkov radiation?
That's the name, and it's due to the interaction with the structure of the water. The absorption, it produces a bluish glow. So have you ever seen that?
Not naturally, no. I've just seen photos
It's
of it.
beautiful. Now, I think that the reactor possibly at WSU, it's a form of a trigger reactor, is it not? And I think that there probably is a similar glow with that, with the reactor that's over at the Pullman campus.
Oh, wow. Well, maybe I'll get the chance to see that
Sometime
someday.
when you're over there, it would be interesting to drop by and have a look at that facility.
Yeah, it sure would. So then you said that you worked on this project up until with the cobalt and everything, FFTF up until the mid '50s, right? And then what did you do after that? After the project?
Well, it
with
was
the-
about 1969 when it went into the boron carbide work. The boron carbide work continued until 1986, and at that time, I became a part of the group that was doing the design for the joint experiments with the Canadian and Japanese scientists on blanket materials, absorber materials for use in the FFTF. That's when
Right.
we started designing that facility. And I think what made this work so interesting was that usually we were in on the design phase of it, and then followed it through from the fabrication of the experiment, getting all of the approvals, safety approvals, and so on, actual construction, inserting the experiments into the reactors, starting them up, and collecting the data. So we could see from start to finish how the project went. And I think this had a lot of value because that way there was feedback. You could see how you might have done a project in a different way, and it would suggest other ways of doing things. I think many times a designer may not have that privilege of being able to see the end result and knowing whether the decisions made in the design were the best ones to make. So I found that was really an exciting part of doing the work, to see something through from start to finish.
So you have to forgive me because I'm not I just want to make sure I'm following and understanding everything correctly because I'm not a nuclear scientist. When you say blanket materials, what is a blanket material?
A blanket material is the material that was proposed to go around a fusion energy machine. Now, fusion energy has been, its advances have been very slow and very difficult to come by. But right now there is a fusion machine that is being built in France. But they need to confine a plasma to get the fusion of like deuterium and tritium or various elements at the low end of the periodic table to fuse together to release energy. The fission energy comes from the process of fissioning elements at the high end of the periodic table. In the fusion energy, the work that is being done, they are proposing that there would be an intense field of neutrons present, and that some of these neutrons could be absorbed in what they call the blanket. And the blanket was the area immediately surrounding where the fusion is taking place. So we were just doing materials, evaluating them to serve as materials that could surround that would be in the area surrounding a fusion energy device and absorb these neutrons, thereby making some tritium that could be circulated back into the fusion machine, so it could be making some of its fuel. Products typically lithium. When you bombard lithium with neutrons, you will produce tritium from that. So many of the materials that have been proposed involve the use of lithium. So the work that we were doing in FFTF was examining potential materials that could be used in a fusion apparatus.
So that's not shielding then, that's materials to help, I guess, in a way moderate the reaction, but capture that tritium to recycle back into.
Exactly. That's a good way. It would be a way of producing more fuel that could be used to fusion. Yes.
Because a fusion is bringing the atoms together, right, which produces an immense amount of energy.
That is
true.
So
is that blanket material there also there to capture that enormous amount of energy? Or is that just to capture the other atoms made by this fusion?
It's more, I think, to capture the neutrons to provide a feedback process for fuels to make more tritium atoms to put back into the process to keep it going.
Wow.
So that was the purpose of working on those materials for that.
Oh, that's really fascinating. So now so France, you said, is building the first fusion
reactor. There are other nations. I'm not sure which nations now are involved, but France has been behind this for a long time. Interest by the United States lagged for a little while. Probably 10, 15 years ago, and they had cut back some on the support for that. But then some advances were made, and it looked like it was really something that the United States should be involved with. So they are still a participant in the fusion energy research that's going on.
And how long did you work on this blanket material project with Canada and Japan?
It went from 1986 until I believe the FFTF reactor was shut down in 1992. And so that 6-year period was when we were working with the Canadian and Japanese scientists. The Canadians had much experience in tritium work because they use heavy water reactors, and the heavy water reactors do produce some tritium in the process. So some of us took classes up there in how to safely handle and capture tritium. What the Canadians came up with, their contribution to this project was that in the FFTF, when we would be irradiating these materials and making tritium, we would be able to adjust the temperatures and look at how fast the tritium was released from a material, depending on the temperature, and what other gases were present. This sort of information. All of the tritium that was produced had to be, it was swept out of the reactor. A helium line went in with extremely high, less than 1 part per million of impurities in the helium, because we didn't want any activation of any impurities in the gas to be swept out of the reactor. And that gas, the sweep gas that went down over the samples, came back out, went into all this instrumentation that was in this large glove box. And so we had to capture all of the tritium that we made. None of it escaped to the outside at all. So the Canadians came up with highly efficient materials that were a combination of zirconium and some other elements to capture that tritium. They would actually form hydrides or tritides, a combination that they would react with it and tie it up so that it was a stable compound. And it would, since the tritium has a very soft beta emission, we would typically have maybe a couple of thousand curies of tritium in a tube that was approximately 1.25 inches in diameter by about 12 inches long, but it was completely shielded. You couldn't detect any information on the outside of the capsule, yet it contained huge amounts of tritium, but it was all captured, and that's what the glove box one. It contained all of the materials, the chemical materials that were needed to capture the tritium.
Oh, it's interesting. So the hydrogen would be able to sweep up basically the tritium and become tritium laden.
Yes, that's right. The helium would sweep out all the tritium, and in some cases, if we used a little bit of hydrogen mixed in with this ultra high purity helium, then would be able to sweep it out much faster. It seems like the materials would react with our samples, and we would sweep it out, so we would see rapid releases of tritium from the material, which is important information to have, because if you're going to extract this from a fusion machine, you might want to know how to get it out of your compounds faster.
Right.
But so those experiments continued on then until the FFTF shut down, and then I worked for about 3 more years after that on instrumentation for the waste tanks out at Hanford. Much of it was involved with that tank that would periodically release bursts of gas. The burping tank, yes. And that was instrumented too. They had various kinds of gas instrumentation installed right there at the tank. The controls for it were in a trailer parked right next to the tank farm fence, and so we had continuous monitoring on that, and I was involved in some of the operation and maintenance of the helium gas analysis equipment.
Oh, wow.
So I worked on that until I retired then.
And you retired in 1995?
Then 95, yes. That was
From,
right.
so what? So 44 years.
44 years was I had worked out there, and it was I can think of nothing in the way that I really want to change. I always felt that we were working very safely. I feel that we really had a good knowledge of what we were doing at the time.
Sure. I want to kind of come back to a couple of things you mentioned earlier, and maybe just kind of ask you more about the kind of the social, cultural aspects of living in Richland. So when you mentioned that you had moved into a dorm for your first few weeks here in North Richland, which I imagine those were dorms for the Hanford construction camp.
Yes,
Right.
they had used some for that and some for other workers, because at all of the housing, even in downtown Richland, was controlled by the government. So you got on a list and you got high enough priority, then you could move to more desirable location.
Right.
So by the time I came back after traveling around the country for a year, I had moved up on the list and was eligible for a dorm in downtown Richland.
Ah.
These dorms were built on Jadwin between Swift and what's the next street north of there? Not Simons.
Williams?
Williams, that's it. The dorms were located in that general area there. And then there were some other dorms for the women employees that were down approximately where the Albertson store is now.
Right.
And so
Photos of
that was the two locations for those. I was in the dorms for only maybe about 3 years, or not the dorms, the single dorm rooms, and then I was able to get an apartment on Gribble Street. There were some apartments along there, and I rented an apartment there for a while until I then later bought my own house in Richland.
Your dorm. So, were there mess halls that went with the dorms, or
There-
were you? Did they have kitchens? I wonder if you could describe the dorms for me, kind of how that living arrangement was.
The dorms were single occupancy rooms. And, as a matter of fact, there may still be one of those in use in the city of Richland.
I've heard there's one off Jadwin.
On Jadwin. It is, where is that? I can see it.
Someone told me.
It's on Van Giesen.
Van Giesen. Right,
I think it's on Van Giesen between George Washington Way and Jadwin.
Yeah, they said it's by the 7-Eleven.
Yes, there's a 7-Eleven on the corner of Jadwin and Van Giesen, and about halfway down that block on the north side is one little building, and I think it still may have rooms for people that rent that just want a dorm type room.
Interesting. I drive that way home every day. I'm gonna
look again too. I'm
Yeah,
gonna
I'm gonna
look
see
and
if I
see
can find it.
if it's not still there.
Because that would have been one of the Alphabet House dorms, right? I think they were the J.
No, I think they were they were mostly the M's and W's. There was an M1, M2, M3. I lived in M5 for a while.
Okay.
And the women's dorms were similarly numbered W. such and such.
And the Army gets very creative
Yeah.
in its naming
Yeah,
system.
and there were some restaurants and cafeterias in Richland. One of the cafeteria type operations was on that corner just across from where the federal building is right now, at the corner of Knight and Jadwin.
Right.
It was on the southwest corner. They had a large facility, eating facility in there. But that was pretty much the way the dorms were. All right. One of the things that I do kind of remember there, you're going to have a mix of all kinds of people in a dorm like that. Well, one of the occupants decided he was going to make some home brew. So he brewed up this and then he put the caps on it and everything. He had his own bottle capper, and then he put them under his bed in the room. Well, this tends, especially if you haven't processed it right, it will generate some CO2 gas.
Yeah, well.
And in the middle of the night, these started going off almost simultaneously, more than one. So as the cap would blow off, the beer would come out. It would soak all of the bottom of the bedding. When you walk down the hall, you would think that you were in the local tavern because it was really smelled of. So he no longer could hide the fact that he was making some home brew in his dorm room.
Wow. So you mentioned that there would be all kinds of people in there. So it was was it a mix of like blue and white collar workers or people of all different jobs?
Yes, it was. It was
occupations?
kind of a mix of blue and white collar. Mm-hmm. It really was.
And it would have been all single men, right?
All single men
men's
and
men's
single
dorms.
women. Some of the women worked at the hospital. They worked at in the schools in Richland. But yeah, that's pretty much the way it was.
What if you could describe to me your first impressions of Richland coming in June of '51, coming into this government town where there was no private property and everything was government owned.
Yeah, well, it was really foreign to my way of thinking, but it seemed like there was a real effort once the property was sold, people could buy their homes, and businesses were encouraged to come in to make it a more normal. But it was not. It was an unusual circumstances to be in, and you really didn't have the freedom of choice, shall we say, as to what you could do. You knew that if you were in the government housing that you were only qualified for certain types of housing, depending on how long you'd been here, your marital status, whether you were single or married, whether you had children. If you had more children, you were then you were entitled to a house with more bedrooms, and it was people just kind of adapted to what the conditions were at that time, and it was. There really were a lot of young people at the time that were living here that were attracted to this area, and they were a very enthusiastic group. There were a lot of social activities, groups that even to this day still exist. There was a ski club that was very popular with the young people. Sometimes they would take off, and for especially a 3-day weekend, we could get on a train at Pasco, go to Spokane, switch to another train, and go over to Missoula, Montana, ski at Big Mountain, at Whitefish.
Oh, wow.
And we would arrive over there about 5 o'clock in the morning, and go out and have a full day on the slopes for a couple days, and then jump on the train, get back in, and That first day back was kind of rough, though, because we were getting in early in the morning and have to go to work at 7:30 in the morning. It worked out fine. Other times there were bus trips, chartered buses that took us to Sun Valley for skiing, some of the mountains up in Canada, and it was really a lot of fun. Border crossings were fairly simple at that time. We'd come back and they weren't supposed. They were only supposed to bring a certain amount of the alcoholic beverages back from Canada because of the alcohol laws in the state of Washington at that time. And so when we'd be coming back, typically a border security officer would step inside the bus and look and say, "Well, did you have a good time up here?" "Yeah, we had a good time." "Okay." That was the end of it. They wouldn't check to see whether everybody was within the limits allowed or not, but you never knew when they would check. But security was very much unlike it is now as far as border crossings.
Yeah, kind of a different time, huh?
Yeah, different time.
I like that you mentioned there were a lot of young people. Did that strike you that there weren't a lot of established families in Hanford, that most people here, because you had to work at Richland, or you had to work at Hanford to live in Richland.
That seemed, but I think the town was pretty full. It was an unusual condition, but it seemed like there was always so much going on, and with this group of people that they made things happen for themselves. I recall, this was back in probably the early 50s, we had an engineer join our group working on the graphite, and he was from the Boston area. And that man continually complained, "There's nothing to do. There's this, there's that. I don't have, I can't go to see the latest operas. I can't." And we said, there's a lot to do here. And there was. But he complained so much, and people reminded me occasionally, well, you can always go back. And certainly, and sure enough, he only stayed here about 3 years. He couldn't take it. He was the type of person that needed that big city environment to exist. And it just wasn't the place for it.
Sure.
And so he left. And the area was probably better because we didn't have him around complaining.
Wow. Was the Uptown finished by the time you got here?
It was It was just kind of being developed. The stores were going in and they were gradually added, but it was about that time when the Uptown was being developed. But there was still a lot of sagebrush around, and when even when some of the ranch houses were built out on the west side along the bypass highway right now, they would frequently run into large groups of rattlesnakes that would be locally in one area, and they would have to get rid of them. But it was there were some things here, that you wouldn't expect. But rattlesnakes were one of the things that they had to be kind of careful, even in the 300 area. If some of the buildings had a crawl space underneath where the maintenance personnel would have to climb under there to work on water lines and steam valves and other things, and they had to be extremely careful because there was, and one time right in 306 building, I was working out there one evening and working late, and the only other person, I was on the second floor, and the only other person was the janitor who was working on the first floor. And all of a sudden I heard this scream, and I thought, what is going on? Is that somebody break in and attack that janitor? I knew it was the janitor. And she was absolutely panicked. She was up against the wall in one of the restrooms that was downstairs, and the entrance to the restroom door was within 2 feet of the outside door. A rattlesnake had come in from the outside and made its way into the restroom. She went in to empty the wastebasket. She picked it up, and she was facing this rattlesnake, and she froze and just let out this scream. And I went down there and saw what was under control, and she couldn't hardly talk. So I said, well, we have a way to handle such situations. Don't worry. And we called the person that really, when this sort of thing happened, there was always somebody in the power plant there, the steam plant, that could help out. The person was really an accomplished snake handler. He came over with a plastic bag inside of a wastebasket. He approached the snake, put the wastebasket and plastic bag over it, gently pulled the plastic bag up around it, captured the snake in the plastic bag, and proceeded to walk out the door with this rattlesnake. The last that ever happened, but that janitor and I, we often joked about that incident, but at the time, it was very serious.
Oh, sure.
But the outcome was fine. The snake was returned to its desert environment.
Right. Well, I mean, they did predate humans here. So.
Yes, and there were a lot of snakes. Well, in fact, I belong to a mountain climbing group that typically every January 1st would climb Badger Mountain. They still do on January 1st. And one year we went up there, and it was kind of a warm, sunny day, and we were all surprised to see a rattlesnake sunning itself out on a rock on the very top of Badger on that January 1st day. And so I couldn't believe it, but I actually saw it happen. So you do have to be a little careful, I think, of to this day of climbing Badger, that not venture off too far from the trail into areas unless you have high boots on and are prepared for encountering a rattlesnake.
Wow. No, thank you.
Me either.
What other kinds of social activities did you partake in Richland?
Well, one of the activities that I really got involved with was what was then called the Richland Night Opera Group. And they put on one or two Broadway-type productions. And I usually worked behind the scenes, sound, lighting, that part of the stage group. But I appeared, I think, in 2 shows in a walk-on type situation as part of a crowd scene. I think that was in Fiddler on the Roof was one of them. But anyway, that was a really good group of people, and in fact, it happened to be the place where I met my wife.
Oh, okay.
And she was playing in the orchestra at the time. So there were activities if one wanted to. You really didn't have to search very hard to find interesting things to do. There was no lack of things for me to do. I didn't have the feeling at all like the Bostonian that I needed to get out of town to find some entertainment.
Right. And when did you meet your wife?
Pardon?
When did you meet your wife?
It was probably in the late '60s, at first she was playing in the frequently playing in the orchestras, and I was working on the shows, and so we that was a place where we met, was through the light opera group.
Great.
Very there was a fun group and entertaining group. They you never were quite sure how it shows. Some shows that involved a lot of children, like Sound of Music, they would double cast the show because in one case I remember just about 2 weeks before the show was scheduled to go on, the measles, there wasn't all the vaccines then, and one of the kids in the group caught the measles, but they were over it by the time the show was ready to go on stage for the audience. But it was something that there's always some surprises along the way.
It kind of shook everybody up.
Yeah.
Did you ever buy an Alphabet House or live in an Alphabet
No, I
House?
didn't. I had considered it at the time, but I bought one of the newer houses. Then when I finally got around to buying, I lived in the apartments down there for probably about 8 years or so, and I thought, oh, this is kind of stupid. I might as well be living in a house of my own, and I could do what I wanted with it. And so that's what I did. I got busy with that and became a homeowner. But there were still the interesting things, a lot going on that if anybody wanted. And I got involved with amateur radio operations, became a part of that group, served on with some emergency communications preparations groups. And to this day, the amateurs radio operations are part of the emergency center that we have in South Richland down there to serve as a backup, because in many times they will have the equipment, battery operated or even generator operated power sources that can be used for emergency communications, because I think a lot of people feel overconfident with their cell phones nowadays, but cell phones, after all, also require electricity to run.
They do indeed.
And oftentimes, this is the amateur radio can get through when other communications may fail. And it was part of the technology challenge, I think, of some of these things. I went ahead and studied and progressed through the range of licenses that you can get to be licensed, have my own station, and so on. I get busy with other things like my work, and but still I am a licensed operator and have some of the equipment to get on the air with that.
Oh, cool.
But yeah, it's so like I say, the things, it seemed that I tended to move towards the technical aspects of in the even the recreation and the social, where it was the technical side of the light opera shows that I participated in. But I always found I never lacked for something to do. I always found something that was interesting to do.
Did this radio service start out as a civil defense measure?
Well, it dates back a long ways, where the certain frequencies were set aside more for experimentation, so that operators could come up with new equipment, new developments, antenna improvements, and that sort of thing. So continuing to this day, there are certain frequencies that are set aside, and as times have changed and we've gone more to digital communications, there is a digital mode of communications that I'm working on right now to try to get that on the air that involves very little power. And if you can imagine something 2 to 3 watts, barely the amount of power that it would take for a nightlight, and be able to use that power on a transmitter to talk to Europe is, I think, something that I want to do. And it's being done all the time right now.
Oh,
but
wow.
that's the sort of things, there are people that continually work on contesting to see how many others they can talk to, whereas others are looking at the equipment and how to improve what we have. So there's something there. Even if you want to, you could do digital TV. There are some frequencies set aside for amateur radio experimenters in that field as well.
Oh, cool. Company?
The Savannah, the company that was
Milwaukee.
A.O. Smith. They're the ones that make water. I think to this day they make glass-lined water heaters. They used to.
You said A.O. or A.O.?
A.O. Letter A and O. Smith. S-M-I-T-H was the company. The other Alcoa was the company in Pittsburgh that I'd referred to.
I've heard Alcoa is big.
Oh, they're big. They generally went to experienced contractors that they knew could do the job for them. That would do a good job.
Sure.
And some of them were difficult.
Okay. Ready? Okay. Just a couple more questions. I'm wondering if I want to ask you a couple of milestones in Tri-Cities history. Do you remember any of the Atomic Frontier Days parades or Richland Days parades? And did you go to any of those or involved?
Oh, maybe a few of them. It seemed like the Atomic Days parades didn't last too long. It seemed like it seemed to quickly become a Tri-Cities area event. And then with bringing the boat races in and so on, it was something that was more the whole Tri-Cities event. I do again. It was perhaps an unfortunate event. I was working with radio operators, again providing emergency communications at one of the boat races, and this was probably back in the late 60s, perhaps. Unfortunately, there was a lot of drug activity going on at that time, and I was attached to a Red Cross first aid group, and someone in a group came and asked for help from the Red Cross, that someone had crawled under a car and somebody else had jumped on the hood and had come down and person had an injury, a head injury from this person jumping on the car. And the Red Cross person evaluated the situation right away and wanted to call an ambulance for help, and the friends would not agree to this because the person was on drugs. They said, if you call them, he's going to be charged with drug usage. And they held off probably for at least a half an hour, and they finally relented and said, well, maybe we better just take a chance and have the ambulance come and have him checked out. And they did. But after that, the boat races never had the attraction for me. I was really disturbed by the action of some people that would endanger the life of a friend just to protect them from a drug charge. And I never participated in any more radio activities with the boat races. That was the end of it for me.
I'm wondering if do you remember the JFK visit in 1963 to dedicate the N reactor?
Yes, I do remember that and that time, and it was a very exciting to have the president here for that.
Were you there that day?
I did not go out to it, but we saw the caravan moving out, moved right past the 300 area, and went out to the dedication ceremony. But yes, that was an exciting time for the Tri-Cities for sure.
What do you and what about were you here for President Nixon's visit as well?
I don't recall much of that.
Okay.
But I, as a part of my amateur radio activities, I had attended a Northwest Convention at Seaside, Oregon. They have one of those every year, and we had a speaker there that had been the radio person on Air Force One for several presidents. I think he had served in that position for over 30 years. Wow. And he told us that he was on the flight that took Nixon to China the first time.
Oh, wow. And
he said that he got a call in the middle of the night. He said, Air Force One has to be ready to go all the time.
Right.
Anytime you want to go. He got a call late in the evening, and they said, be ready to go. We're leaving in something like 2 hours, and we'll be at the airport or wherever we're supposed to be. And he said, well, what kind of clothes shall I take? Can't tell you. What anything I need to do, just be there. That even the person that would be on the plane with the president didn't know where they were going until he was on the plane with the president.
Oh, wow.
And discovered that they were going to China.
Wow.
And that's how secret that particular operation was. But he traveled with several of the presidents, and he had some really interesting tales, as you can imagine, someone that served that long and had an interesting job.
Yeah. I wonder if you could ruminate maybe on the Chernobyl accident and how it affected the community here, and how you reacted to it and how others in the community.
Well, it was we were really we didn't know that much about the Russian reactors. We knew that they had graphite moderated reactors, the same as we had. There was a great concern because one of the topics that I did not mention earlier was that in the process of graphite being damaged by neutrons contacting the atoms in the graphite structure, crystalline structure, sometimes the atoms would be displaced. Graphite has a crystalline structure, a layered structure, and so sometimes atoms would be displaced, and this would eventually cause some of the overall expansion that we were seeing. These atoms, as the temperature was increased, could return to a more stable lattice position, and in the process release energy. This energy was called stored energy. Now, there was an incident in stored energy that happened at wind scale, and it only went for a small area in the reactor, and then it kind of self-propagates for a while, and then it terminates depending on the conditions. But we knew that there was a chance for one of these temperature excursions. I believe that it was related to the Chernobyl incident, because they had some temperatures that went up quite high in that incident, and undoubtedly some of it was as a result of graphite damage, being the energy being released. So we had monitored that situation in Hanford reactors for a long time. So some of these samples that we would take out of there, we knew that there was very little concern at that time of releasing stored energy, because we had raised the temperatures enough in the reactor that this was no longer a problem. It's only when the graphite is operated at a low temperature that stored energy can become a serious problem, and one that you have to be aware of. So the Chernobyl, we were aware of what was going on, but it had a little different dimensional situation. It had some unfortunate design characteristics that weren't, looking back now, the best thing to do in the design of a reactor. But there was great interest here in seeing whether we would have any problems related with graphite, and it turned out we didn't have to do anything differently than we had been doing for years before that.
But this stored energy, if enough of it was in the reactor, could release enough heat where the reactor itself could overheat.
Definitely, that is the case. Yes, and there was a small reactor, I think a Brookhaven reactor, and that was an air-cooled reactor, and so it didn't operate at high levels for a long time. But nevertheless, it was definitely a concern with the people reacting that, because it's the low temperature, long time periods that will cause that stored energy type damage.
Interesting. Wow.
Yeah.
So one of my last questions. So you were, I think your career is really remarkable, because you came here in this kind of early 50s, when the construction's ramping up, and then you saw, the eventual drawdown, and then kind of probably the fights to save the different reactors and an FFTF, and you were still working here when the decision was made to shift from production to cleanup, and that kind of the whole mission changed. I'm wondering if you could describe your overall feelings and recollections on that shift between production and cleanup, and how it affected you and how it affected your coworkers, the people you worked with.
Yeah. Well, I think that we could see that with the shutting down of the reactors, that the place would be entirely different. It was hoped by many people that there would be more power generating facilities built here by Energy, WPPS at that time, but that wasn't to be. So I think many of us were encouraged to see that something that should have been done much earlier in the way of processing the waste was finally going to be recognized, and people could move forward with that task. The approach that they've taken has been a long one and a very costly one, but they are making progress to converting that waste from a liquid form to a solid form for storage, and I think everyone is very happy to see that happen and wants to see it proceed as quickly as can be. But as far as the research opportunities, there were, even though there were budget uncertainties along the way, and as we see the reactors were shut down, it seems like there was always something else for us, a next step to see in the way of the research side, like the FFTF work, and Battelle was steadily increasing their staff on research and doing other types of research, both government and private. And so it still seemed like a good place to work and be. And this area has so much to offer. It really does. And so most of us didn't give too much thought in moving immediately because we were afraid that the place was going to just deteriorate and go back to sagebrush. We could see that there was more ahead for the Tri-City area than that, and stayed here and enjoyed it until now.
So you're saying that there was a general feeling, at least among some of the workers, that cleanup, that dealing with the waste problem should have been tackled earlier on in the cycle, because you said you were happy that something which should have been done earlier was finally being done. Do you think do you think there was a general feeling that should have been handled earlier on than kind of waiting until making that the main focus? It should have been happened earlier.
I think a lot of people felt that way, that because everybody knew that there was a finite lifetime to these tanks, and they were well beyond their design expectancy, that they would be a suitable place to store waste. And so I think that they were really wanting to see this proceed. The facility that they're designing out there is extremely complicated, and Savannah River has been vitrifying waste for quite a while, but on a smaller scale. It will be good to see the facilities out here finally end up producing solidified waste for storage, because it definitely needs to be done. We can't keep it in the liquid form forever like that without expecting deterioration in the tanks and so on, the very sorts of problems that we're experiencing right now.
Sure. I wonder, how did you, living and working in Hanford through so much of the Cold War, did you ever feel an immediacy of the Cold War on your work, or did you feel that your work was linked to different events in the Cold War? How much of a presence of that was in your life?
Not really a lot. We didn't really think too much about that. We were our focus was more short term, perhaps, solving the problems at the time. The one of getting the graphite expansion, which was limiting the life of the reactors, was a big effort to solve that. And so on a day-to-day basis, I don't think that the result of this and its tie-in with the Cold War didn't seem to have a big impact on the people that I associated with.
And my last question, what would you like future generations to know about working at Hanford and living in Richland during the Cold War?
I think that they should know that personally, I felt that I was working in a very safe environment. I did not feel that I was endangering my health in any way during that time. And sincerely, they had very ambitious schedules going on to meet, but nevertheless, it was always done with safety in mind. And I think that bears it out because we have had an excellent safety record here. So I feel that I was probably safer working here than in some industrial environments. I really do.
Yeah. Well, Don, thank you so much. I really appreciate you taking the time to come
welcome.
and come and talk with us today.
Yeah.